Hey everyone, today we are going to learn about a very important topic, that's what's the difference between monocoque chassis and ladder frame chassis. So today we're going to learn about these two constructions, these two structures in detail. First of all, we'll see what they mean, and then we'll deep dive into one of the features. We'll talk about the pros and cons, which one is better, for what purpose, and everything. So let's start. So on my screen, I have shared two figures. One is on the left, this one, it's called ladder frame chassis, and this one, it's called monocoque chassis. So, what's the difference? If you look at the construction of both these frames, it's clearly evident from the pictures, from the figures. The structures are totally different. So, ladder frame exactly means uh, it looks like ladder, right? You can see two rails, two steel rails, two metal rails connected by multiple cross members. So it looks like a ladder. That's why it is called ladder frame. And monocoque. What does it mean? Monocoque in French means single body or unibody. So you can see there is no separate ladder frame like structure, and the whole body is bolted or welded. In fact, welded into the floor panel and everything. It acts as a single body. Okay. So construction wise, this is the difference. And why it is like that, we'll come to that later. But yeah, that is the basic difference in shape. Then ground clearance. Usually ladder frame chassis has more ground clearance than the monocoque body, and because these two rails are heavy, that's why obviously the fuel efficiency is going to be lower here in this case of ladder frame chassis. Then comes to torsional rigidity. So what is torsional rigidity? That we'll talk about it a little later. But just be clear on this, that torsional rigidity is higher in monocoque chassis and lower in ladder frame. Then comes to the body repair. So the whole body of the vehicle is bolted onto this ladder frame, so it can be easily removed, and another body can be fitted. So you can swap bodies in case of ladder frame structure because of the construction, because of the shape. But here in monocoque, as you can see, the whole body is welded onto the floor panel. There is no separate ladder frame like structure, and the body cannot be removed, so it's not swappable. Okay, so typically ladder frame is used in SUVs, pickup trucks, then off-road vehicles, heavy duty trucks. So they typically adapt to this ladder frame chassis. And monocoque chassis is typically used by almost all hatchbacks, sedans, luxury cars, sports cars. All of them are using this monocoque chassis. And monocoque chassis is useful for better handling and uh, commercial use, normal day-to-day life usage. But ladder frame chassis is best for high payload and rough terrain, off-roading, and pulling heavy loads. Okay, so let's see some examples. What all bodies in what all cars or vehicles use monocoque or ladder frame. So one popular example is Mahindra Thar. You can see here, Toyota, Fortuner, all the SUVs mostly use, and along with the trucks and buses, they use ladder frame chassis. And almost all sedans, hatchbacks, be it i20, i10, Honda City, whatever, almost all of them use monocoque chassis. Okay, so feature wise, this is the difference. Now, what are the pros and cons of both these structures, both these chassis? So here it is ladder frame, and On the right, monocoque. Let's see what are the pros. Ladder frame chassis can carry heavy loads, so its payload capacity is much higher than monocoque chassis. Okay, and then as I already explained, the body is mounted on the ladder frame, so you can swap bodies easily. You can use the same ladder frame but different bodies. So easy body swaps is one of the pros. Off-road durability is higher in a ladder frame. And then towing and trailer use simple field repair because the frames and the body is separable, so you can easily repair any damage happening to the body. Okay, but in monocoque it's significantly lighter. Because it is lighter, so it has better fuel efficiency. It has got high torsional stiffness. So what it is, we'll deep dive into it maybe in the next video. One of the most important thing is better crash safety. So this is the most important thing about monocoque chassis. It gives better crash safety. And how? We'll take this portion today and we're going to see why monocoque chassis offers better crash safety. Engineered crumple zones. So what are crumple zones? We'll talk about it in detail. Then monocoque chassis has lower ride height. That's why it has better center of gravity. And if we have better center of gravity, then obviously the rollover will be less. So we'll talk about it also in future videos. And another important thing is monocoque chassis provides you quieter cabin. The NVH noise, vibration, harshness is usually lower in monocoque chassis. Why it is like that, we'll talk about it. Then coming to the cons. I've already explained ladder frame has overall weight much higher than monocoque chassis, so that's why less fuel economy, and the bodies are easily swappable. That's why the repair cost is very low in case of ladder frame, but it is higher in monocoque chassis because there is no body swaps. Platform is fixed and the whole body is integrated by welding to the platform. And higher center of gravity in ladder frame chassis, that's why rollover is much more. And as far as crash is concerned, monocoque offers better crash safety. So today we are going to focus on this one, this particular feature or significant advantage of monocoque chassis, that is better crash safety. And why? We'll take a small example, very simple example, and through math and physics we'll compare both ladder frame and monocoque chassis, and we'll prove that monocoque chassis provides better crash safety. Okay, let me go to another tab. So we'll see. Why monocoque is better in crash. So for this, let's say we'll compare two vehicles, one with monocoque chassis, one with ladder frame chassis. Okay, so let's assume let's talk about a vehicle which has mass. Let's cover two vehicles. Both of them are having mass 1500 kg, and let's say they're traveling at speed 56 kph, kilometer per hour. Okay, so we'll compare. So 56 kph is like 15.6 meter per second. Okay, so we have ladder frame here, and we have monocoque here. Okay, so the scenario is there are two vehicles, both of them are having mass 1500 kg, and both of them are traveling at 56 kph. Uh, why 56 kph? 56 kph is a reasonable speed, usually adopted in crash tests and cap. Okay, okay. Now, as I said, there are two cars. One is with ladder frame chassis. One is with monocoque chassis. Okay, so let's talk about what happens in ladder frame. So as I said, so both of them are moving at 56 kph. So let's calculate the kinetic energy of both the cars. Half mv square. So half 1500 into v square, that is 15.6. So if you calculate this, you will get around, let me calculate, okay, 182,000 joule. Okay, that is 182 kilojoule. So here also same, because mass is same, velocity is same, so you'll get 182,000 joules. Okay, now, so the vehicles are moving at this speed and it crashed into a wall, let's say. So when it crashed into a wall, the total kinetic energy will come into, so the vehicle was traveling at 56 kph. Now it crashed into a wall, so it stopped. That means the vehicle's velocity becomes zero. So all the kinetic energy, as per the conservation of energy rule, all the kinetic energy must be converted into some other forms of energy, right? So where will this kinetic energy go? It will be transmitted totally, completely into the body of both the vehicles, right? So, and so as you know, ladder frame has two rigid frames, right? So its deformation distance, deformational distance, let's say d, because it is very rigid, because of the rigid structure in ladder frame, it will be around, it's very less, right? So very less, so it would be like 0.15 meter, let's say, assume. And here in monocoque chassis, there are crumple zones present here. So it has a bigger deformation distance. Right? It will be around zero point 0.6. Okay, so this is the key difference between monocoque and ladder frame. This is going to play this deformation distance because of the construction, because of the structure of ladder frame and monocoque. Okay, so this deformation is much more. This deformation is much less in ladder frame, that is just 0.15 meter, whereas in monocoque chassis, because the structure, we'll talk about it little later, there are many crumple zones present in the monocoque chassis, so the deformation distance is much more. Deformation is much more in monocoque chassis. So now what will happen? We know that this kinetic energy will totally be converted into some other form of energy that will be totally absorbed by the body or the frames or the chassis, right? So uh, this 182,000 joules of energy will be completely transferred through the deformation to the body. So if as you know, the work done, the kinetic energy will be converted into this absorption energy and that will be transmitted to the body. So how much force will be transferred through this energy conversion? So if T is the deformation, we know the formula of work done, F into D. So F will be 182,000 divided by this deformation 0.15. Okay, and here it will be, let me denote it by letter FL, and here it is FC. Here it will be 182,000 divided by 0.6. So if you do the calculation, it will be roughly 1213000 Newton, and here it will be 304 200. Let me, this is just approximate calculation. So okay, I'll make some corrections. 182,520. So this is actually, I made some mistake. This is 520. Same here, 520. Okay. Okay. So as you can see here, in case of ladder frame, total force on the occupant will be this much. And in here it will be 304. Okay, so it is 1213 kilonewton. This is 304 kilonewton approximately. Okay, so you can see from here total force on the occupant is much higher in case of ladder frame, almost 4 times. Okay, so let's say there is a passenger sitting in the car. Let's assume his weight is 80 kg. So what will be the acceleration on that passenger? Just divide it 1213 by 80. It will be approximately 83 g. G is nothing but the gravitational force, right? And here it will be 304 divided by 80. It will come around 21 g. If you do the calculation, kilonewton and this is kg. Okay, so this is the basic difference. Okay, so as you can see from the calculation, in ladder frame the g force acting on your body is 83 times, whereas the g force acting on your body in case of monocoque chassis is just 21 g. 21 g is also very dangerous, but still it is much lower than ladder frame chassis. So in case of a crash, the same vehicle but with different construction, with the same mass, same passenger, same velocity, the vehicle with the ladder frame construction is experiencing 83 g deceleration on the passenger, whereas in the monocoque chassis the passenger is experiencing 21 g force. So it's clearly evident from the calculation that the monocoque chassis is far better in crash, right? So from safety point of view, usually passenger cars are designed with monocoque chassis. So just in case, God forbid, just in case somebody meets with an accident, the injury will be less. Okay, so that is the basic difference, and it is very. And so today in this video we covered one very important aspect of the designs and its impact on the crash safety, right? In the next video we'll cover two more features of these two constructions, and we'll compare what the advantage of which frame over the other. Thank you.